Hello, my name is Navid Rezaei, and I'm a PhD student at the University of Alberta. The title of my talk is Learning by Prompts for Visual Common Sense Tasks. So recent research has shown that larger language models are very good at few-shot learning and zero-shot learning. But the problem is that these language models become quite large, and this makes them not really suitable solution when we deal with on-device applications, for example, mobile systems, or for example, for autonomous systems. So in our work that is focused on common sense reasoning, and specifically visual common sense reasoning, we try to find another solution for smaller devices. So if you use smaller language models, the problem is that we need to train them to fine-tune them on some data sets that are usually annotated. For example, and that opens another challenge, which is the cost and time for creating that kind of data set. For example, one data set that we looked at spent around $240,000 for just annotating that, and that does not include other costs and time value of the people involved. So the goal is to find a method that is quite generic, that doesn't need much architectural change in the models. And we have found that prompts are quite promising. So far, we have seen around 60 to 65% reduction of annotations needed in a common sense data set that we have. So yeah, I'll talk about the data set later. So first, let me tell you what kinds of prompts are usually used in literature. So the first paper that we have here has the, or adds the types of classes, the target classes and classification to the question, which is passed through a language model. So for example, what is the sentiment of this sentence, and we add positive or negative, and negative to that sentence as a prompt. Another way which is used in T5 model is prefixing with some task descriptions. For example, saying translate English to French, and we have an English passage, and the output is going to be some French. Another way is to add some sentences or sentence-like structure to the question, so that we could add some generation from that point on. And another method that is used in GPT-3 is similar to T5, but they also add some samples of the task as well, some examples of that. So the data set that we have is a data set focusing on common sense reasoning, and the data set is multimodal, so it has both images and text, and it also looks at what the future events or previous events could be, or even the intentions of people based on the common sense of the scenario. So some of the prompts that we have added are shown in this slide. For example, some of the concepts that we have here, or even facial expression, or even captions. So in terms of image captions, we can see that if we use 25% of the data, we can we get better results than the GPT-2 model, only the GPT-2 model without the prompts. And also the relevant concepts, we can see more improvements as well. And also for facial expressions as well. And now if we combine them, we can see that if we use around 40% of the data, we can almost match the 100%, the results that we get with 100% of the data. And we can see by this work, we can enable the construction of a cost and time effective smaller model that is kind of capable of supporting non-stationary autonomous systems in situations which usually require common sense reasoning. So we have some future work such as creating better prompts, evaluating the best combination of the prompts, and also quantifying the effectiveness of each of these prompts. And we can also see if we could automate creation of these prompts. So that's it, and have a great day.